Dear student, I am Professor Varun Kumar, Ajay Kumar Garg Engineering College, Department of Computer Science and Engineering. Today we are going to discuss the theory of automata and formal languages, and my topic is Mealy-Murray machine conversion. So what is Murray machine? It has 6 tuple, that is Q, sigma, del, small del, lambda and Q naught. What is Q? Q is a finite set of state. If we are going to construct a machine which is represented as a Murray machine or either a Mealy machine, these following tuples are followed, that Q is a finite set of state, or we can say that the non-empty set of states. Then second symbol is summation. Summation is the non-empty set of input alphabets. And this particular machine it produce some output. So we are represented capital Del as a output alphabet. The collection of all different type of output alphabets. This particular set also a non-empty. Then del is a transition function, that is summation cross Q into Q. It means that it also follow as its transition function is similar as a DFA, deterministic finite automata. And another thing is that is lambda, that is the output function which map the state into the del. And last one is the Q naught. Q naught, as usual, Q naught is an initial state which is presented in a machine. Oh, what about the Mealy machine? Mealy machine is also having the same 6 tuples. There is only one difference, that the output function of a Mealy machine is depend upon the present state output and the present input. This is the table of the Murray machine. There is some present state. In this particular machine, we have 4 different states. Q naught behave like a initial state. There is 2 input type, that is 0 and 1. This is the next state transition that is represented by del, that Q naught gets input 0, then produce Q3. This is the transition function. Then Q naught we apply 0, then we reach to the Q3. And if we are on Q naught state and we input as a 1, then we reach to Q1. And the state directly represent the output. It means Q naught representing the output 0, then Q1 representing the output 1, and Q2 represented as 0, and Q3 represented as 0. So we can say that output of Q naught is 0, and output of Q1 is 1, and output of Q2 is equal to 0, and output of Q3 is equal to also 0. Then this is the table for the Mealy machine. As usual, we are saying that only difference is the output function. Here output is depend upon the state and input both. Then in this particular system, we have 4 different states, that is Q1, Q2, Q3 and Q4. Q1 behave like a initial state, and we have the 2 different input symbols, that is 0 and 1, and output symbol is also 0 and 1. So we can say that if we get Q1 and we get input 0, then it reach up to the Q3 and produce output 0, and if we give input 1, so it reaches to the Q2 and produce output 0. And similarly for the all states. Here we represent like this, that Q1 is an initial state. If we get input 0, then we reach to Q3. If we put 0 as an input here, then we reach up to Q3 and produce output is 0. So we write that 0/0. This is representation as of input. This is for output representation. So we take some example of this particular, how we convert transition table into diagram. This is the transition table, and we are going to draw this particular table, convert this particular table into the diagram. So we have there his 3 state, that is Q naught, Q1 and Q2, and we assume that Q1 is a initial state and A and B is the input symbol and output symbol is 1, 0 and 1. This particular table is represented as a Mealy machine. So we draw some diagram. We write here Q naught state and output is 1. We observe that Q naught having the output 1. So we write Q naught as output 1 and there is initial state. We put arrow here. So this is the initial state and second state is Q1. That is Q1 and what is the output? That is 0. So we write here 0. Q1 state represented as a 0 output. Then again Q2 and Q2 represented in the table that as a 1. So we write Q2 as a 1. Now we complete all the transition. If Q naught we apply our input A, then it reaches up to Q1. We apply A, then we reach to the Q1. Then if we apply B, then we reach to Q2. Then in Q1, if we apply A, then it reaches to the Q1 only. If we get B input, then we also get to Q1. So we write A comma B, both the input, it reaches up to the Q1. As we know that this particular table, that Q2 input A, it reaches to the Q1. So we draw the arrow Q2 to Q1. And similarly for B, this is the transition diagram for the Mealy machine. Okay, fine. This particular table now represented in this particular transition diagram. This is also another machine. We are represented as a Q1 as a initial state and all the transition that Q naught output 0, Q1 output 1 and Q2 output 1. And all the transition, we write all the transition, then A, Q naught get A, then reach to the Q naught, and on B, it reaches to the Q2, and Q1, it reaches to the Q1, and B, it reaches to the Q naught, Q2, get input A, it reaches to the Q2. So, self loop. So, Q naught get input B, then it reaches to Q1. This is also similarly you can draw this particular table into the diagram. There is 4 state, then output Q naught 0, Q1 0, Q2 1 and Q3 0. Then put all the transition. This is the old transition. Similarly, this numerical, it have 5 states, then all states are represented and put output that Q naught 0, then Q1 0, Q2 1, Q3 0, Q4 again 0. Then complete all the transition, put initial state Q naught as a initial state and draw all the transition like NFA and DFA. This is also another transition system, that is, this is the transition system, transition diagram. How will we draw this table? Conversion of diagram to table. This particular diagram represented 2 states. So we have, this is the table header, that is the present state. Then next state when input is A, because input is A and B. 2 different type of input symbols are there, that is A and B. So we write input A and input B and output produce 0 and 1. So there is 2 state Q naught and Q1. The Q naught get A, then it reaches to the Q naught only. Then Q naught input B, it reaches to Q1. And what is the output of Q naught? Q naught state is represented output as 0. So we write 0 here. So what about Q1? Q1 input A, it reaches to Q1. Input B, it reaches to Q1. And what is the output of Q1? That is 1. So we write here 1. So we complete total diagram. This is the procedure how we convert this particular transition diagram into the transition table. So this is another example. So you can try it. This is another example. You can try and check. This is also a, you can check yourself. One special condition is there, that what about the Q2 output? Because Q0 output is fixed as 1, Q1 output is fixed as 0, but there is no output produced by Q2. So we write here epsilon or null symbol here. If your diagram or transition diagram having any not having any symbols, so we put here epsilon or null, like in epsilon move and FA. This is also another diagram, so we can directly convert this particular table. This is for Mealy machine. How we write this for Mealy machine? How many number of states are there? 2. And what is the input symbol? This is represented as the input. Input is A and B. What is the output? Output is 0 and 1. If Q0 get input A, it reaches to Q0, and what output is produced? That is 0. So we write here 0. If Q0 get input B, it reaches to the Q1, and what is the output? B, output is 1. Then another state is Q1. Q1 get input A, it reaches to again Q0 and produce output, that is 1. Then put B, when B, it reaches to the Q1 and produce output 0. This is the complete diagram. Then one another example, you can try this. That Q0 state, okay, and Q1 state, for Q1 state, Q2 and Q0 and produce output 1. Then another state Q2, for A it reaches to the Q0 and produce output 1. And for B it reaches to the Q2 and produce output 1. So then another example, you can try this. We consider blank state as a Q2. If any transition system not having state name, then you put your symbol for state, that is Q, and take another number. Q0 is there, Q1 is there, so you can write Q2, Q3, Q4, etc. Then this is the table for Moore machine. So we draw the transition system for it. We know the procedure how to convert table into diagram. So we convert this particular table into diagram. This diagram represented as a Q0 is equal to 0, Q1 is equal to 1, and Q2 is equal to 0, and Q3 is equal to 0. We extract some output from this particular table. If we are going to convert Moore machine into Mealy machine, so we have to extract something. That is what is the output function. That is Q0 represented as a 0. So we write here our extraction, that Q0 is equal to 0, Q1 is equal to 1, Q2 is equal to 0, Q3 is equal to 0. And we convert this table into the Mealy machine table. Mealy machine table having the header, that is the present state, input and 0, input 1, next state, output, next state, output. There is 4 state. So we write here all 4 states, that is Q0, Q1, Q2 and Q3. At input 0, what is the output? That is, what is the next state? That is Q3, Q1, Q2 and Q3. So we write here Q3, Q0, Q1, Q2, Q3. And what is the next state? If input is 1, that is Q1, Q2, Q3 and Q4. So we write here, what is the output? What is the output? What is the output it produced? That Q3 state is represented as a 0. So we write here 0. What is the representation of Q1? Q1 represented as a 1. So we write here 1. What is the Q2 representation? Q2 representation is 0. Q3 represented as a 0. Q1 represented as a 1. And Q2 represented as 0. Q3 represented as 0. Or Q0 represented as 0. So this is the complete table for the Mealy machine. Okay, right? What we have extract from this table, that is Q0 is equal to 0, Q1 is equal to 1, Q2 is equal to 0, Q3 is equal to 0. Simply write Q3, what is the value of Q3 here, what is the value of Q1, Q2, Q3 and so on. This is the complete procedure how we convert the Mealy machine into the Mealy machine. So this is our output and we convert this particular table into again a diagram of Mealy machine. This is the state representation. There is 4 state and we draw all the arrows, input oblique output, input oblique output, input oblique output, input oblique output and input oblique output, then input oblique output. This is the input and this is the output. Then this is the input and output. This is input and output. So this is the complete procedure how we convert this particular Mealy machine into the Mealy machine. In the AKTU examination, either you have the table or you have the diagram. If you have the diagram, so you first convert this particular diagram into the table, then you extract outputs and then redraw again table of Mealy machine, then paste particular Mealy machine into the transition diagram. This is the step number 1, this is the step number 2, then step number 3, then finally step number 4. In total 4 steps, you convert the Mealy machine into the Mealy machine. We take another example. Convert the following Mealy machine into the equivalent Mealy machine. This is the representation of this particular transition diagram. There is 2 states, that is Q0 and Q1. Output of Q0 is 0, output of Q1 is 1. There is 2 different input symbol, that is A and B, and initial state is Q0. So we draw this particular table, that is Q0 as a input A, it reads to the Q0, in B it reads to the Q1. Procedure is already I have discussed. Then you can easily convert this particular transition diagram into the transition table. So what we have extract here, then second step, that Q0 is equal to 0 and Q1 is equal to 1. Then we convert this particular table into the Mealy table. This is the table for Mealy machine. We convert this particular table into the Mealy table machine. That is, what is the output of Q0? That is 0. We extract here that Q0 is equal to 0, Q1 is equal to 1. So we have write that Q0 is 0, then Q0 is 0, Q1 is 1, then Q1 is 1. And Q0 is a initial state. So we represent it as a arrow as a initial state. Then finally, the last step, this particular table converted into the diagram. So we have the table, that is again same table is represented here. Then we can draw this particular diagram. So Q0 A input, then we reach up to Q0 only, then output is 0, then output is 0, then on input, second input, that is reached to the Q1, then reached to the Q1, and what is the output? That is 1, then first input, it gets to the Q0 and output is 0 and 1, self loop, B, output is 1. You can try this particular numerical, that is Moore machine into its equivalent Mealy machine. First you look the diagram. There is 3 state, that is Q0, Q1 and Q2. Q0 have the output 0, Q1 output is 0, Q2 output is 1. In our transition system, it has 3 different states, that is Q0, Q1 and Q2. There is 2 different input symbols, that is A and B. There is 2 different output, that is 0 and 1. All transitions are given into the diagram. So we convert this particular transition diagram into transition table. So we have the 3 different states, and what is the initial state? That is Q0 is the initial state, and Q1 and Q2 are the non-initial state. There is no representation of final state in either Mealy machine or Moore machine. In NFA, DFA, there is at least one final state must be there, but in Mealy Moore machine, it is a finite automata with output, so outputs need not require the final states. In this particular machine produce some output, so we consider output only. So we have the output function, that is lambda. This particular table is represented. What is the output of Q0? Q0 output is 0, then Q1 output is 0, and Q2 output is 1. Then this is the table. Then second step, this table is converted into another table, that is the Mealy table. This is the table for Mealy machine. What is the output of Q1? That is 0. What is the output of Q1? That is 0. Output of Q1 is 0. What is the output of Q0? That is 0. Q2 output is 1. Q0 output is 0. So we convert this particular table into another table of Mealy machine. Then last step, this particular table is converted into the transition diagram. So this is the table, and we are going to draw the Mealy machine diagram. So in Mealy machine diagram, Q0 is initial state, and there is 3 state representation. So we have 3 state, that is Q0, Q1, Q2. There is 2 input symbol like A and B. So all state having the transition function over A and B. It produces some output in terms of input oblique output. So we match here that Q0 for input A, Q1, 0, A, Q1, 0, Q1, and output is 0. And similarly, you can easily draw. Then next example, convert this Moore machine into equivalent Mealy machine. If we study this particular table, then there is no diagram is given for this particular Moore machine. In AKTU examination, you also have the table and convert this particular Moore machine into the Mealy machine. So we extract our tuples here, that Q is the different states. So there is 3 states, and Q0 behave like a initial state. There is 2 input alphabet, that is A and B. There is 3 different output symbol, that is 0, 1 and 2, and Q0 represented as 0, Q1 represented as 1, and Q2 represented as 2. So we convert this table into another table, or we can use our old traditional method, that is the transition function. If you can easily convert this particular table into diagram. Then what we have going to do, that table to table conversion. This is the Moore machine table, and this is the Mealy machine table. State and input. Input is A, input is B, state and output. what is the Q naught? Q naught is represented as 0, Q2 represented as 2, Q1 represented as 1, Q1 represented as 1, Q naught represented as 0, and Q2 represented as 2. And finally, this table is converted into transition diagram. And this is the transition diagram. Then you can try this particular. This is the convert this following machine into the equivalent Moore machine. This is the table of first step is the transition diagram into table. We convert this particular diagram into the table, and we are going to extract what is the value of the state. Q1 is represented as 1, Q4 is represented as 1, Q2 is represented as 1, Q3 is represented as 0. There is no conflict at all. But what will happen that if Q2 is equal to 0, Q2 is equal to 1. Q2 have two different values, that is 0 and 1. And what about Q3? Q3 have value 0 and Q3 have value 1. Q3 also have a two different value, that is 0 and 1. What about the Q4? Q4 have value 1, Q4 have value 1. It means what is the value of Q4 is 1. What about Q3? Q2 have two different value, that is 0 and 1. Again, Q2 also having the value, two different value, that is 0 and 1. What about Q1? Q1 have only one value, that is 1. This is what we have extract from this particular table. So first, what we will get, that Q1 is equal to 1, Q2 is equal to 1 and 0. And what about Q3? Q3 have 1 and 0, and Q4 is output is 1. So in Moore machine, state directly representing the output. Output is directly function of the state only. So we convert this particular state Q2 represented as a two different state, that is Q2 0 and Q2 1. This particular state Q2 represented which Q2, which produce output 0. So we associate the output symbol with the state name, that is this is the Q2 1, and similarly for Q3. So we convert this Q3 into two different states, that is Q3 0, which have the output 0, and Q3 1, which have the output 1. So in this particular table, we observe that Q1 have value 1, Q2, this is for both states are represented as a Q2. This Q2 is belongs to the output 0, this output 1. Both state represented for the Q3 0, which output is 0 and 1, and rest of the transaction are the same. But what will happen then if we observe that Q1, then we get Q1, then we put Q2, so we get Q2, but which Q2? Because Q2 have two state, Q2 0 and Q2 1. Which Q2? Which Q2? If we get input, if we have state Q1 and we apply input B, we reach to the Q2 and output produce 0. So we reach to the Q2 0. So we write here Q2 0 here. Okay, fine. Then what about Q2? Q2 say output is 4. So okay, we have both the state for transition for Q2. Then what is the output? That is Q4. Again, there is no problem. Then Q3 output is Q2. Which Q2? Then which Q2? Which Q2? Which produce output 1. So we write here Q2 1. Both transition for Q3. So this Q3 for input B, we get Q3. Which Q3? Which have output 1. So we write here Q3 1. Rest of the transaction are same. What about the Q4? Q4, Q3, which output is 0. So we write here Q3 0. Q4 for input B, it reaches to the Q1. So we write here Q1. Okay, fine. Then finally we convert this particular table into the diagram. This is a particular appropriate diagram. You can try this, convert this Mealy machine into the equivalent Moore machine. You take your time, convert this particular diagram into the table, and then convert table into the another table. Then finally table into diagram.